Hey there guys and gals, it's me nirex and welcome back to yet another Unreal Engine video. Now I know this might look a bit different from the last video, and yeah, because I actually I actually made this video, but the content was good, but it got so out of sync. I don't know why. It got just so terrible that I had to redo it, and this is that version. Anyways, so I haven't really done a lot in terms of doing things. The character in my blueprint is okay. Nothing added, nothing. Everything is already good. But I did do some stuff with my C++ character. Now I'm gonna go ahead. Oh yeah, I added a camera. All right, so that's the only thing that I did. Now I'm gonna go ahead and first off do something here. So if I go here right now, if I take a blueprint character, all right, and take this guy out like completely, and try to possess myself here. Remember, it has a camera, right? So I'm gonna just go ahead and possess player 0, play it, and as you can see, I can turn it around. I just can't turn up or down. All right, I can't look up, I can't look down, only left and right. Okay. Now this is a problem you will face if you just put a camera without doing anything, which you kind of need to do. So what we do here is kind of quite simple. As you can see, when we want to do look X and look Y, all right, we add yaw input and pitch input to controller. Okay, so we gotta need to adjust this with our camera. So let me just go back here because I forgot what it was. Yeah, use control rotation. So come here, set use control, come on, control rotation. Oh yeah, pawn control, whatever, same diff. So we're gonna set pawn control rotation. We're gonna set it to true, and we're gonna make it happen on construction or begin play. Yeah, whatever. We're gonna do it with begin play. Doesn't really matter. So yeah, this is all good. Now if I play it right now, you can see that I can look up, look down, look around, move around, all good, right? So this is basically what you should do when you create a camera. And now the only thing I've done here is I've given it a new camera component right here, visible anywhere, whatever, and meta. It's a new thing. Don't worry about it. So visible anywhere, blueprint read write, all good and dandy. Then I came here, yada yada yada, the same bullshit that we always do, create default saw object, whatever. And now there are a couple of things that I've done that was not in the last video. I fixed some stuff, right? So I did this, set up attachment to root component, and again, set up attachment to root component. I fixed the capsule size. And this, basically what this means is that, whenever we create that, remember that bug where when I dragged something in, some of the things were right in the center of the map and I had to adjust them manually? Well, this basically takes care of that, alright? This basically means, okay, whatever this guy is, it's going to be under this. This guy is going to be the parent of this guy, alright? This is basically what it means. Okay, now, the same bullshit that we do here. Now, there's a note here to be made, alright? Just explaining to you all the things I've done, then we're just going to go ahead and go to coding it. And the issue is this guy right here, alright? It's giving me an error, if you can see it. If you can read it, IntelliSense is telling me that member whatever, declare that line 76 of, whatever, is inaccessible. Alright, it's basically what it's saying is that you can't set this to anything, it's private. But if you peek definition right here, you can see that there's nothing on the top, it's not public, and we know classes are private by default. But here's the thing. Generated uClass body. Okay, this is some bullshittery with this goddamn IntelliSense. Some major bullshittery happening right here. So this guy right here, all right, whatever it might be, generate body, generate uClass body, whatever. These guys, this has a public modifier, so it's basically the same as this. This itself has a public modifier right here under itself. All right, so whatever comes under this guy, it's automatically public. But because IntelliSense doesn't know that, it's going to give me an error here, saying that, alright boy, you can't really use that because it's private, while it's not. It's entirely public, I assure you. Okay, now that we got that bullshit out of the way, let's get into you know, the actual line trace or raycast or whatever the hell you want to call it. All right, so I've done something else. Yeah, I didn't really clean my project app. So where was it? Edit, project settings. In the inputs, I actually added one more input action input, or action mapping. Where was this guy right here? Which is interact with the key E. All right, this is the only thing I did as well. All right, interact with the key E. Okay, now let's go ahead and do line tracing in Blueprints. See how it's done. So we're gonna do in interact. Right, this is the kind of events we're gonna do. Now I only want to do the thing that I want to do in the what is it called, in the pressed event. All right, I don't care about the released one. So we're gonna go ahead and do that. When it's pressed, we want to do Raycast. Now Raycast is called line trace in Unreal Engine. If I type Raycast, Raycast component, you know, some bullshit comes here. But we also have some line trace stuff popping up for us when I search Raycast. I could also do line trace. Now there are three types of actually two types of different line traces. There's a single line trace and a multi-line trace. Now this will give you a simple object, all right, and multi-line trace by channel. This will actually give you an array of, you know, whatever it hits. Now we're gonna actually talk about a whole lot of this. I'm not gonna do this in this video, but it's kind of obvious. This will not have its own video because it's very obvious. I'll actually show you how it's done. Okay, so let's actually get to go here. So what you need to do is, first off, we need to understand what's happening. So what the hell is a raycast? Because a lot of tutorials just go without explaining what it is. Raycast is basically a laser being shot from point A to point B, or in this case rather, start to end. Okay, so it's a laser that goes from start to end, and it whatever is in the destination, right? Whatever it hits on its way will be given out as the result, and we can do whatever we want with that thing. All right. It's pretty good for I don't know, interacting with things. All right, interacting with people, opening and closing doors. I don't know, turning on and off a light. Not your flashlight, another light. Shooting people, you know, it's goddamn amazing for FPS shooting games. This is the only way to do it. I mean, obviously not with a goddamn RPG or something like that. You know, just normal weapons. And so yeah, that's the basic use case of line trace. Now there are a couple of stuff here that I'm gonna actually explain to you right now. Then we're gonna go to code and see how it's done. So we have a starting point and an end point. All right, now it's gonna automatically detect how to go from start to end. We just got to give it the start point and the end point, and we will do that. We have a trace channel visibility. Now this is a kind of what do you call it? Kind of an advanced thing. We don't really care about it. All right, trace type query. We don't care about it. Trace complex, true to test against complex collision, false to test against simplified collisions. Basically, what it means is that it's you know, if you have some sort of custom collision type, this is kind of a good boolean, good thing to check, good switch. Actors to ignore, you could give it a set of actors and it could automatically ignore if it hits those actors. Like you have a trigger box with some special collision and you want to ignore that, you give it here. You make an array and give it here. Everything that's in that array, the types of the actors, or not the types rather, the actors itself, themselves rather, will be ignored. We have a draw debug line, which will draw a line from point A to point B. All right, the line color will be red. Whenever it hits something, it will become green. Now there are a couple of debug types we have for one frame, which it will just draw it for one frame, as it's obvious. For duration, which you will set here, and persistent, which will be persistent throughout the game. It will always be there, which I'm going to set to persistent, just because. Or, you know, why not? Duration, who cares? So we have that, alright, input action, line trace by channel, whatever, all good. Now what I want to do is, I want to shoot something from the point I'm looking, alright? So wherever my camera is, I want it to shoot out of my camera and then go wherever it's going. Alright, so I want it to shoot out of my camera. Okay, in order to do that, I need the location of my camera, right? So let's get world location. We get the location of the world, the starting point, which is obvious, and we get something else from this. We want to get the forward vector. Now, forward vector is kind of a normal vector, and normal vector basically what it means is that it's a x and y and z cannot go more than 1. Okay, and this is basically what a normal vector is. Yeah, this is kind of a normal vector right here. Gives you the forward direction in the world space. Kind of a math bullshit, so don't worry about it if you don't understand. We get the forward vector, and then we do times by something. Because it's a normal vector, it's tiny, so we want to actually make it bigger. Let's do 5,000. Alright, so we'll do that. Add it to the end, and that's it. Now let's talk about these two values. These two outputs. These were the inputs, and we only care about these two mostly. We don't care about any of them. And these two are the only ones that you actually care about in C++. The rest are bullshit. This too, alright, this is an important thing as well. Now let's go ahead and do, some stuff with this. Let me just go ahead and break it. You've already seen it in the collision video, in the overlap video. It's a simple hit result. Blocking hit, ensure overlap, time, distance, the distance from, these two. Location, which is another vector in the world space. Impact points, exact location where the thing hit the thing. The normal, impact normal, and physical material, hit actor, you could get all this stuff. But this is mainly the one. These two are the main ones that we care about most of the time. All right, not a lot, not all the time, but most of the time. So let's go ahead and see how it's done. I'm gonna actually go ahead and print the name of whatever actor I hit. All right, so let's go ahead and do print text. And what we want to do is we want to attach, actually get name, actor name, come on, get display name, yeah, why not? We're going to get the display name, gives us a string, we turn that string into text and print it here. Let's go ahead and compile and test to see if it's working. So as you can see, it's already good. Cube 2, cube 6, it's been drawn for me. Alright, as you can see, it's quite cool. And whenever we hit, as you can see, the rest of this thing, wow, that's some bad bullshit over there. So whenever we hit something, the rest of the line will be green. Alright, and this is basically what it is. This is basically a line trace. Now you could do whatever you want with these line traces. You could shoot something and it could just turn it off or turn it on or deal damage and break it, or just do whatever the hell you want to do with it. All right, you're free to do whatever you want to do with this amazing thing, and every engine has this topic and every tutorial covers this topic because it's a very important one. Very important. It's a need to know. Okay, so this was the basic shit that we did. Now I'm gonna go ahead and use just these to create my my C++ way of doing things. Alright, so what I'm gonna do is I'm gonna go ahead, the .h is, well, not quite ready. What I need is a function. So ufunction, and whatever function, and I'm gonna name it void cast ray. And it's gonna take nothing, and that's it. Alright. So this is my header file. I'm gonna go down here. Void my character cast ray, takes nothing, and that's it. Okay. Now let's go ahead and actually do the line trace. So the first thing we're gonna do is I'm gonna actually let IntelliSense load the shit so I can use IntelliSense to see what's up here. I'm not gonna use anything else. Okay, line trace. The name is line trace single by channel, I think. Line trace single by channel. Line trace single. All right, it's get it. Oh, okay. Yeah. Get world line trace single by channel. See, you gotta, some of the things are in the world that are related to the world, and this is pretty goddamn obvious, pretty logical. You want to do line trace in a specific world, and this is your world. Okay, you don't want to do it in the menu. So we get the world, we do line trace single by channel. Let's see what it gets. It gets an out hit, which is of type F hit result. It's this guy right here, right? We give it out. It doesn't return anything, we just pass it out, okay? It actually returns a boolean. And we have a F vector start and F vector end, E collision channel, trace channel, which is like okay. It's ECC visibility. It's this guy right here. You could do either visibility or camera, like ECC camera, whatever. And then we have const F collision query params, which is just just a CQP, and it's already given. It's the default thing, so we don't really give a damn about that. Told you, the only things that we care about are these three and this guy right here. It doesn't do any of these fancy things for you, it just does a simple line trace. So let's go ahead and make the first parameter that we want, which was, and let me actually go ahead and do that, zoom this guy in. F hit result, pointer, F or out hit is new F hit result. Now F hit result is pretty good. If I just go ahead and peek the definition, as you can see, it's just a simple struct of engine API type of, just a struct. It's not a class. It's not in sort of an actor or whatever. It's just a simple class. So we can new it, without any issues. We don't need to do this kind of bullshit here. It's not a component. Where is it? We don't need to do this kind of bullshit. Okay. So the first parameter was a hit result actually. So we give it that. Now we have two vectors right here. All right. We have the start vector and the end vector. Also, we need to dereference this because it was a pointer type, so it needs to be a normal type. Now we need two vectors. So let's go ahead and see what it's up. What it's all about. F vector starting point, or rather, let's actually call it just start. Is new. Well, why do it newly? Let me just go ahead and get the camera component. So we do camera component because we're exactly doing what we're doing here, right? So we want to get the world location. Get world location. Well, we have set world location. Okay, we could do, oh yeah, because it's a component, we gotta do get component location. Get component location. There we go. All good, all dandy. Gives us the world location for that. So now we have the starting point, which we're gonna give it start. Now we need an endpoint. Reminds me of network programming. A vector, end is, okay, what the hell was end? We get the forward vector of the camera, so camera component, get forward, get actor forward vector. Wait a minute, why is it not giving me the forward vector? Forward. Okay, what the hell did I use up here? Get actor forward vector, yeah, obviously, come on. You can do that. You can do that, bro. So we get actor forward vector. It's not giving me that. Yeah, it's right goddamn there. I don't know what's wrong with IntelliSys. Yeah, so we get that, whatever it might be, and then we times it by some float value. Doesn't really matter. So let's do 5,000. Why not? 5,000 floating point, and that's our endpoint. So let's go ahead and give it end. Now we have one more thing. Which is the trace channel, and that's just easy C visibility, right? Just memorize this part. Alright, so we have done this part. Now, it's already handled here on its own, but line trace could fail. Okay, it can fail to happen. It might not shoot it at all. So we need to check for that. Let's just put this guy in an if. If it returns true, which means that it's been done flawlessly, then we can continue to do whatever the hell we want to do. Alright, so we have already hit something. Now let's go ahead and take care of this bool right here. This guy basically means, is the out hit result empty or can I use it? Okay? True if there was a hit, false otherwise is the description given for that boolean. Okay, so let's go ahead and see what's up. Now, the first thing we're going to do is draw the debug line, because we don't care if it was hit or not. We just draw the debug line. So we draw debug line. Now, I'm not going to do any fancy shit like this. You know, you got to do 2 debug lines, whatever it hits, and after that. But I'm just going to do some basic debug line. So draw debug line where in the world. So we get the world. Line start, obviously from start. Line end. And if color, we give it some color like green, and then there is you know, whatever. We could give it persistent. Yes, definitely persistent. The lifetime and all the other bullshit. We don't care. So this is my debug line. Good. Now that that is taken care of, let's go ahead and see if this bool was actually okay. So what I'm gonna do is something like this. If we get the out hit, okay? Now if you remember, out hit right here has an actor inside itself. So we get the actor, get actor. Now if this actor is not empty, we're gonna do what we're gonna do. So if this returns anything but 0, then we're gonna go there. And anything but 0 means there's actually something in there. Alright, so we got the actor, and if it exists, then we can continue with our amazingness. Okay. Now, what to do? We could do a couple of things. Do I do this or do I destroy the actor? Whatever. We're going to do print debug message, I think it was. Debug. Whatever. Debug. Screen. What the hell was it? Screen debug. Nah, I don't remember that. Why do I not remember that? Whatever. We're gonna delete the actor. So we're gonna do get actor, or whatever, out hit, get actor, destroy. Thank you very much. And just like that, we have easily destroyed our actor, or whatever actor we hit. So all cool and good. I just don't remember the prints. Oh god damn it! It's right up here. How did it not? God damn it! Come on. So we do if G and G, dude. Come on. What we want to print is the text version of this guy right here. So we get out hit, get actor, get display name. Wait, display name? I don't know why it's not giving me that. Yeah. Or is it like this? Get display name. No, I don't know. What can we get from the actor? Let me actually check that thing. You know what? Whatever. Nobody cares. We're gonna go ahead and destroy that goddamn actor. Alright, so we don't care about the name. I don't know exactly how you do this, but yeah, you could just go Google it and it's like that. So we're gonna go ahead and destroy the actor. You know, all good, all dandy. Let's go ahead and test and see if it works. I'm pretty sure it's gonna work, but we're gonna test it anyways. Alright guys, as usual, it took a goddamn long amount of time for this shit to compile. You know, whenever you change anything, you just, you know, change one single thing in your .h file, it's gonna just, I think it's recompiling the entire engine. It's just a goddamn lie. Hot reload. That's how long it goddamn takes. Anyways, enough ranting. So, yeah, let's go ahead and see and test. Ah, damn it, I forgot something. So, yeah, where were we? Yeah, luckily we don't need the .h for this one. We just need the need to work with .cpp. So, I created my cast array. I created everything, but I forgot something. I forgot to map it to my action that I've made. So I'm just gonna go ahead and copy this. It was unpressed, if you remember. No, quite simple and easy. Already good and dandy. It's unpressed, so we only care about the pressed key. Now we're gonna go ahead and make a function out of this. So we're gonna give it cast array, and it's gonna, oh bro, come on, it's gonna hit on interact. Also, while it was compiling, I made this character C++, so don't worry, it's my character, not my BP character. So I'm going to go ahead and compile this again, and hopefully it compiles faster this time. Alright, compiled a lot faster. Let's go ahead and test. Yep, it works. It goddamn worked pretty good. As you saw, yeah, bro, we're all going down together. And you can actually move in air, so that's some nice shit right there. Okay, so as you can see, it all works. As you can see on the top right there, my what is it called? My thing works overlapping. My raycasting works, and the lasers are there. So yeah, it's pretty goddamn good, and this is the way you do it with C++. Now, I promised I would show you something else before this video ends. So it's basically the same principle. Let's go ahead and see what it is. So we get the world, and from that we do line dude, yeah, actually good one. All right, so this is the multi-channel line trace, okay? Multi-line trace by channel. So the only difference it has is that you need to give it a T array. All right, so T array is an array that Unreal Engine guys made. It's kind of like a vector, but better. It takes f-hit result, and that's it. You know, out hits. And then you could simply just give it that, and the rest is the same. So we do start, we do end, we do ICC. It wasn't ICC, it was ECC, visibility, and that's it. All right, that's how we do this. Anyways, that's been it for this video, guys. I hope you enjoyed it. I hope you learned something, and if you did, do leave a like. And you know, if you actually liked this video, do leave a like. Don't leave a like if you didn't like this video. And yeah, what was it? I wanted to say, yeah. If you have any questions, do ask them in the comments. I'll try to get to you as fast as possible. And if you really enjoyed this video, do subscribe for more content like this. And yeah, so that's pretty much it. Thank you for watching. I will see you when I see you.